Everyone, for this month of On Air with BioBytes, we have Dr. Samir Brahmachari. He is the founding director of CSIR IGIB and he is pioneer in the genetics in India.
So then I asked them to write an algorithm for Bombay Dabbawala. Finally, I tell biology has become too serious a subject in last 50 years that it cannot be left in the hand of biologists. So I went to St. Xavier's College where there was no politics. And I took chemistry. The reason is I was interested in biomedical interest. It might sound funny that if you look at the number of people who got physiology and medicine Nobel Prize, you will see most of them are physical chemists, physicists, but they contributed to biology, everybody. So I knew if I do chemistry, fundamental chemistry, and then I have strong maths and I can learn more physics, I should be able to get into medical at a later stage. As I said, the scholarship did not cover medical, right? You can't join MBBS. I'm glad that I did that, and the scholarship was very nice, so I could buy books. When teachers will teach a chapter, I'll buy a whole book and read. It was a very well-funded scholarship. So that took me to do masters in Calcutta. And I did physical chemistry as my master's. And then I came to Bangalore because I was interested to move to biology. So I joined molecular biophysics unit as to do PhD. You can get that story in there is a book published by University of Science in 2008 in 100th year when I got the Best Alumni Award of the University of Science. So there I've written the story, how I came to University of Science. So if you have been to Calcutta, you'll realize that Science College is in the middle of market, Raja Bazaar. And there you come to University of Science, beautiful, pristine campus. So you say, this is the place I want to be. So University of Science influenced me enormously to open up, to learn everything that I wanted to learn. I realized that I've seen G.N. Ramachandran. Subsequently, I saw C.N.R. Rao. There was a Shekharan. I could see these people did great science sitting in India. So there's no need that I have to go abroad to do science. So my aspiration as a PhD student when I joined was how to use G.N. Ramachandran's letterhead as a professor of biophysics, as a PhD student. I used to take one paper, departmental letter, to write to my mother that one day I want to have the right to write this as a professor. So you can see very young days I was very clear that I wanted to be a scientist, I wanted to do science in India, and I have to find a girlfriend or marry somebody who would like to do in India, who is also a scientist who can spend time, and I was very lucky. So I finished my PhD very fast. I finished in 3 years and 10 days. I could publish some 10, 11 papers. Then I went only for a year to France as a postdoc, although I had a fellowship for 3 years. Then I decided to come back to India, do science here. So that's how my scientific career began. Yeah, you have to understand, we went through a colonial era. So our entire thought process of science was very Western. Because if you look at, we had a very great science background from Aryabhata to Ayurveda. But because of colonial reasons, right, British brought quantitative science in India. And then thereby I have written an article on it, that how slowly and progressively institutions were built and science was done. If you go back to the context of Indian independence, you'll realize the scientific activity of CSIR was 1942, was started as a war effort. by Shanti Swarup Bhatnagar. And then subsequently, we have been reading British style books, no? So you will read more about Einstein than about G.N. Ramachandran.
Yeah.
So which most of the surprise to me, students coming from Tamil Nadu doesn't know who is G.N. Ramachandran. Okay? Whereas you go to the Oxford, Cambridge and ask, they will all know who is G.N. Ramachandran. So this is our colonial problem, that we could not project our own achievements, right? I'm glad that Dr. Abdul Kalam at least created a spirit of Indian young people to find role models around, correct? But we missed a lot of great scientists in this process.
Yeah.
You know, Bose-Einstein statistics was done in Bose. So those days there was resource less, so you will see physics was done more, because 19th century, 20th century was physics century, 1900, right? Biology was descriptive till 1950s, right? So therefore, if you look at science as it evolved, from alchemistry to particle physics to understanding, you know, all this happened. And all this happened in the Western world mostly. Indian world, knowledge generated were very mathematical. That's why we say star, astrology, these, that, movement, you know, including our great Jantar Mantar. They're all demonstrated availability. And today, of course, the space programs and all. But it derives from more physics and maths. That's what Indians were strong at, because it didn't resource. So biology came much later, right? So the way science progressed, if you look historically and read some historical book, you will realize that application, the first computer would have taken this whole room and done a calculation which is your mobile can do much better. You know, I just saw a new mobile has come, Samsung 10 Plus or something, with 1+ terabyte storage. Right? Just imagine 1 terabyte storage is in your pocket. Correct? So what has happened? Everybody wants information. Today, science is no longer restricted to the laboratory and scientist. Science has become citizen science. Entire citizen is empowered of storing information, giving information, processing information. So I will say that computer science and computer science, bioscience, those students are doing, I think they were lucky, because computer science has already given us in the pocket a terabyte storage. But as I'm talking, my brain is processing. We are still not there, right? Facial recognition. There's so many things has to be explored. Human body is so fascinating, correct? So this fascinated me. That's how I moved continuously, understanding biology, then went biology, then the, molecular biology. So you can evolve. As I said, I did science as a hobby. I'm lucky that my profession paid me. So in your life, there's an ikigai principle. You do what you love, you do what you are good at, and then you are paid for it. This is ideal. Like you like playing violin, and if somebody pays for it and you are good at it, why do you do something else? You don't need to do computer science, correct? You can be a Rahman, a music composer. So I will say, I was lucky that all these three I had, but your ikigai is not complete unless you do things what world needs. Right? So in the beginning of your young days, you passionately built abilities. And that time you do what you love, you do what you are good at, make yourself more good at, make yourself more comprehensive, you are paid for it. Yeah, you can ask a question. My daughter will ask this question when I was retiring. He said, if you are so smart, why are you not rich? Correct? So all of you would like to be rich. But you respect Abdul Kalam, who was not rich. So there is a contradiction in our life, right? So I say, if you are able to do what you love, if you are able to do what you are good at, and if you are paid for, right? And if your work eventually contributes what world needs, then your ikigai is complete. Then you are a happy person. So I think until 42, 43, I was focused on the first three. Okay? Completely. Right? That gives you award, recognition, published papers, then you want this, that, everything. Then I have that stamp of G.N. Rama. So I got the job as a young 28 years, as a faculty at Indian Institute of Science. And then I became professor. Then I felt that my ikigai is not complete unless I do something which world needs. So that created my moving to Delhi to build the Institute of Genomics, bring genomics to India, convert some of our knowledge base into diagnostics. Today my younger student, Vinod Skaria and others, Farooq and in IGIB and Mitali and others, they have taken that work forward. And they are all allowed. Now there are services. So many diagnostics are in the market now. So therefore, I moved and continuously what I love. So I realized that future of Indian science belongs to young. We have a huge difference has happened. We all grew up with poverty, we had lack of confidence, so we had difficulties in challenging. Although there are a couple of JNR or people who challenged the world and did extraordinary work, I think we went through a patch when India was very poor. Okay? And, but you all are born, this young generation, haven't seen that poverty. Correct? Although you are surrounded by poverty, I'm not saying you are not. But you are not poor, right? Most of you who are privileged to reach all this place. So therefore, your confidence level is much higher. So I discovered that the younger people are smarter. So I decided that I will only work with younger people, right? So I decided by the time I'm 65, I told Indian Institute of IGIB that I'm thank you for 20 years of my time I've spent with you. And then I decided to accept to be a triple I. So genome, just like you have the atom bomb project of Manhattan, it was a coordinated physicist work. Landing man in the moon is again large number of physicists, mathematicians, coordinated work. Human Genome Project became, all these days biology, chemistry was individuals, right? Human Genome Project became the world's first biology project where coordinated effort was made. So I was very lucky to be associated with this very early days. I was very lucky to be elected to the Human Genome Organization in the very inception. So I had the exposure. We didn't have the resource, but whatever within the resource that could be done, we have done. So I could see this is the future. I used to talk and tell that get the information technology guys into this, because what is DNA? 3 gigabytes, bits of sequences. So little. Today, terabyte we talk. What is 3 GB? Nothing. Right? You use 3 GB to see a movie every day. But how it programs from your fertilization to your death, unbelievable. How is this information stored, retrieved, utilized? So if you ask me today, if I was young like you, I'll only deep dive into understanding human using information technology. I'll look at a human as a information processing machine, right? Just imagine if we can create a machine, we are talking about artificial intelligence, okay? Artificial intelligence will be far behind than what is called integrated intelligence, where human-machine interface, right?
Yeah.
But what you and I are doing, we are doing interface, continuously telling, you are asking, I am talking, is impossible. Google cannot do this at this moment. We are, next few decades it will take. You are lucky, you are young. This revolution will happen during your adulthood. And you are in the beginning of that journey. Indian Genome Variation came when I came to Delhi. The project was taken up after we had a lot of doctors' help. So I knew doctors who were working on epilepsy, ataxia, then AIMS and Bangalore, schizophrenia, bipolar. So I had a choice to decide, should I work on simple problem or very difficult problem? So, when you work in India, you have to work on which world is not thinking to work, right? Then you have an advantage.
Yeah.
In 1980, there is a paper was written by Francis Crick and Ogle saying that majority of the DNA, which is repetitive DNA, is junk, has no function, and it will be futile to work on it. It will be intellectually sterile. So I realized America will not get funding for this, right? But I've got the Inside Young Scientist Award, so I'll get funding, right? So I said, I will work on this because I believe this has function. So my early days, strategy to work with a limited resource, that gave the reward today, right? Now today, everybody is talking about junk DNA is no longer junk, it is functional, how these repeats are functional. So that came into discovery of miRNA work that we did, which are conserved non-coding sequences in the genome. So everything went from one to the other, but it was all curiosity driven, okay? The second activity was planned activity because I realized that if we have to provide genetic diagnostics to people of India, there should be a reference information. No company or organization will spend 25 crores to create a reference database. But if public data is used as a reference database and made into open source, then it can be used by others to develop. So our Open Genome Variation project was to create that. We were the first country where we created the genetic landscape of India with 55 populations to map them all disease risk and other risks, at that time whatever was available. So today that is in the, if you go to Calcutta Museum, Anthropology, you will see it starts from human evolution and ends with this chart which we published, that the genetic landscape of people of India. I think that's great feeling, right? You understand? If your lifetime, but it was all possible because it was a teamwork. You have seen 158 co-author of that paper, right? 76 students involved in it, 24 faculties. So that was a big coordinated project. So I'm very proud to say that India's two large coordinated published papers, 158 authors, I have coordinated. So that's a big pride, right? And the team then took off. Everybody did that and went off. So we have hundreds of papers coming out of that particular project. But I'm not an author. Consortium is an author. I believed in that. I believe that it's important that each individual does and takes forward. Then my computational colleagues came and told me, we want to do something similar size. So we started working on a biosuit project with TCS was partner, involving 32 scientists, 18 institutions, and we built the biosuit. We published it, but unfortunately it did not get into large-scale distribution of that software because TCS changed its business plan, okay? They brought it into a service model today they do using, they're learning $400, $500 million annual business, okay? So you can see the TCS has a big opportunity of job for young people, okay? Therefore, it's not that they were zero. From zero to $500 million business. It is there in the website, you can see that. So this has come because they started that bio-IT business in 2001 or 2 like that. You got it?
Yeah.
So therefore, what is tomorrow, right? At 2001, I realized when we were talking into this personalized medicine, today everybody talks about personalized medicine.
Yeah.
So I asked myself in 2001, Ayurveda was personalized medicine. So there must be knowledge, which is several thousand years back. But nobody will fund you to do that time. But I felt what we learn from Indian genome variation, there is so much variation, and based on that variation is actually drugs can be or tasks can be done. So therefore diagnosis, if we can do it with Ayurvedic principles, which sits on 3 axes, Vata, Pitta and Kapha. And a combination of this is all of us. So if you put us in a Cartesian coordinate 3-dimensional space, most of us are in the space, X, Y, Z. Some of us are in XY plane, some of us are in YZ plane, and some of us are sitting on X, Y and Z axis. Correct? According to Ayurveda principles, these individuals have different disease risk, right? So you have a projectile of your career as life as a T0 to T1. In this projection, if you deviate one, then you have a disease process. Your Vata goes up, then you'll end up with hypertension, whatever it is, something like that. So individuals are different. Like so many people go to high altitude for hiking, right?
Yeah.
But several people cannot do it because they will fall sick. So we discovered that people with particular type of Vata, Pitta, Kapha combination are actually high risk to altitude.
Yeah.
And which was then validated by actual genomics and expression and sequencing. And we discovered the gene which is connected to that. So we realized it is actually a great opportunity. And we can say that we decided that genomics and Ayurveda can be merged and called Ayurgenomics. So this is the first time we talked about Ayurgenomics. And today, under Dr. Mitali and Bhavna Parash's leadership at IGIB, it's now a center of excellence of Ayush, and they're doing a lot of work. So you can see, I am a Gemini. So my interest comes and goes, right? And I just, in science, you can be 3 types of scientists, or 4 types, I tell. You can be a lion who will do the killing, do the first flesh will eat of the deer, then leave it. Then the hyena comes, eats the rest. And then when a hyena goes, then the eagle comes, finishes it. I love the lion's role in science. Do the first and then leave it to others to take it forward. I can tell you that taking it forward also is very painful, very hard work. It needs huge commitment. But you need disciples, people who believe in you, right? That this can be done. You want them in the beginning. You cannot be having them. So when I decided to do open source drug discovery, came out of a little frustration because we discovered new drug target for TB using genomics and computational modeling. But unfortunately, no pharma was interested. They said, there's no business.
Yeah.
I got very frustrated. We discovered a genomic marker by which you can use a low-cost drug for asthma patient. The pharma said, it doesn't do good business, right? And if I do it once, they will not come back. So give me diagnostics where patient will keep coming back to me, so I can keep making money. This is cost me a very huge frustration, right? which means all that knowledge we have developed, we cannot give it to the public.
Yeah.
So that's the time Raghav also is open source, Dr. Raghava. So I said, chalo, we'll go open source. What has happened in genomics is open source. What has happened in Android is open source, right? Today, 95% of the big supercomputers run by Linux, which is open source. Then why not drug discovery? So that's how OSDD started. Why it started that way? Because I realized we have to look at a system. Can I grow? My dream even today is to create a human being in a computer and treat with salt to deep pressure goes up. Then put an SE inhibitor and reduce. So that was my dream. How to build a human and models for disease in computer. Then I realized it's very complex. 20,000 genes. I don't think it will happen in my lifetime. Okay? That's the time Seattle Institute of System Biology actually gathered 100 engineers, 100 computer scientists, 100 biologists, hundreds of millions of dollars to start what they call building human in the computer. Okay? I had met Leroy Hood. I saw his aspiration. But in America, you can always create more aspirations and resources come. Yeah. And there are also talents you can bring. And one of the Indian is leading there now. Yeah. So I thought I'll take a smaller organism. TB is what bothers every day. 1,000 people die in TB. So if I can do modeling of TB in a computer. So this was my dream. So in order to model all reaction that happens in a bug, TB, in computer, we needed to read about 55,000 papers published. Tell me in my laboratory, if I get 10 students and say read 55,000 papers, next day I will have only one student left, everybody will leave. So we decided we'll do crowdsourcing. So we crowdsourced 1,200 students to read these papers. They were BSc students, and I discovered young students actually doing better, who has never read a paper. And we could finish in 10 months. Okay, 400 students did a fantastic job, students collected papers, and all information was put into a portal. Once you have all information in the portal, then you know every reaction that happens in the bug. How does the bug work, what happens, everything is there. So this is the time I formally retired at the age of 62, and I decided I don't want to do any more Director General CSIR's job because I wanted to now focus on this data set. This data set was lying from 2013. But there was nobody in India who had a comprehensive understanding of biochemistry, molecular biology, genomics, drugs, these all put together. So I realized that it is I have to do it, right? I don't have a person to do it. So you'll be surprised that the entire putting this 1152 reactions involving 890 genes and 961 chemicals that makes the bug to grow. When I talk to the chemical engineers like Professor Mashelkar, famous chemical engineer, they said, Samir, we can only simulate 12, right, to 16 reactions. We have never simulated 1152. You're talking something we can never do. So I realized I can't get any chemical engineer or experienced people to do. So I managed to get 4 students, 2 from IIT Chennai and 2 from, I think, NIIT Bhubaneswar. And then I had a student who was a computer science man, he was a part of the OSDD. So I told them to write the softwares for these reactions. And I tell you, 1 month, they could write anything. And they come for intern, a few months, that 6 months projects or something like that. So then I asked them to write an algorithm for Bombay Dabbawala, right? Yeah. They said, this we can write. I said, think there are 4 lines, the dabbas are coming from locations and hand it over. Think each dabba is a reagent. When it goes to another, station it changes. That station is an enzyme which does the reaction, and the dabba becomes a product. Product becomes a reactant. Reactant becomes a product. They said, this we will write. So they wrote this. It was very simple then. Then we could create this entire in the computer. Advantage of putting everything in computer is, now you can do computer, ask computer, knock it out, gene by gene, chemical by chemical, you are not doing yourself anymore. Right? What fascinated came out, that when we start putting these drugs, which kills the bug, zoom, you can see all the reactions have gone down. But what we never knew, the new 60 reaction comes up. And then we discovered these reactions, the one which creates this resistance. Bug is so smart, right? Now we had a handle. So now question is, how do I kill the bug, reduce all its functional reactions, but not allow it to come up with alternate routes? Like, as you understand, when you're traffic, you are jam on the one road, you deviate to another road and cross, right? Bug also does the same thing, right? So then one of my students worked hard, and he then picked it up, and we figured out that a diabetes drug, metformin, actually can block bug becoming resistant in computer. No experiment, right? This was a big surprise, but I believed it will happen. Then, of course, we ran through many drugs, many, and we were lucky to see several of them. But this one, people did experiments and found it true, right? In mouse model, in back model. Today, I must say that there are 2 clinical trials is on, one by Indian TB Research Consortium and one by Open Source Pharma Foundation in India, using metformin for drug resistance and drug sensitive patients. So then you can see it starts with curiosity, starts with a desire, and then you have the ikigai. You want to do something that makes a difference for the world. And when that happens, you feel very good about it. Right? But still we haven't been able to simulate a human in the computer. So your job will be to simulate. Simulating a brain will come soon because brain mapping is going on. So therefore, you will be able to simulate brain. Why people love to have a kick, having a shot vodka? What happens? What chemical goes up? So you know that dopamine goes up. Where does it hit? So you can simulate and see what dose of that alcohol actually will be activator, and at what stage it creates depression, and you get into addiction. Right? These are the new challenges. You understand? Finally, I tell, biology has become too serious a subject in last 50 years that it cannot be left in the hand of biologists. It has to be given to the engineers and computer scientists. You see, I mentored a set of startups, and digital health is the future. And these startups are on digital health, very complex data. You imagine we are doing work on newborn child which are prematurely born, and 25% of them will die in sepsis. There are 5 machines when the child is kept in incubator between 8 to 12 weeks. So in the ICU, you call it INICU. And so we developed a method and a portal by which you can capture these informations into a box and then do search engine to figure out. So you taking respiratory temperature, pressure, oxygen, composite, carbon dioxide coming out, and then assess the risk of every child, right? Based on digital analysis. And I can tell you at least half a dozen kids who are passed out of this institute are working on this project in this company. Okay, it's called Child Health Print. It started as in iNiku Cloud when I have the patent and the 2 papers with my student. Then student take it forward, and this is a very successful startup which has got a lot of awards. So same way we're looking at autistic children. How do you take videos of the autistic children, their learning process, and create again an app and a process by which self-learning will be improved, skill development will be improved. So these are all iceberg, tip of the iceberg. Then comes the large data sets, right? In not only in health, just look at it today. So much of flood is taking place in one place. Chennai has a water shortage. Have we modeled? So ecological modeling. You need to understand a little bit of biology and ecology. Without that, you will not be able to do computing. So I will say we had single domain expertise contribution. Today it is difficult. Innovation is across the domain. So each of you have to pick up multiple domain of knowledge, right? And if you can pick up your strength of computing and various aspects, somebody may say, I am not interested in health, I'm interested in environment and ecology. Somebody say, I'm interested to improve the farmer's earning. Okay, so how do I do? Digital, again information. You have the satellite images of the crop production. Can anybody tell me at this moment, with a single button, how much crop we lost in Punjab? We could have. If you have the satellite image of the before flood and after flood, you exactly can give a quantitative information, right? So therefore, these are the future. So your opportunity is based on what domain you choose, and each domain will have huge, huge expansion beyond academia. I repeat, beyond academia. Because if you go to Bangalore, you will see so many startups are on AI health. Asking question it's your curiosity. I recall 1978, there was a conference at Chennai. All over the world people are coming. And we are in Bangalore. And Bangalore was not known. There was no airport. Nobody knows Bangalore. And when we all went as students, and new department, 74 onwards, the department is growing. We were first early batch of students. And so we all went to Chennai. We took a decision that we'll read everybody's work earlier and then go ask questions. So we all ask questions. As we ask questions, everybody noticed us. So when you ask questions, you said, I'm from molecular biology, MBU, IISc, so and so, ask questions. Only MBU, IISc, all over the place, okay? So all senior scientists starts coming and talking to us. So I said, I never made an application for a fellowship. That conference, on my posters, the scientists came and offered me the fellowship. You understand? It's all asking question. Correct? Then they visited Indian Institute of Science from Bangalore. So when the conference ended, I still remember the Dickerson, very famous scientist, he said, when we came to India, we could not locate Bangalore into the map of 78. Who knew Bangalore? Correct? That's a sleepy town, retired Britishers and retired officers' place. Indian Institute of Science is only Tim light there, that's all. But when we are going back, we see Bangalore as a great place in the map of biophysics. That's all because of the questions we asked. The students asked questions. Many of them are in California, here, UCSF, Berkeley, all sorts of places. Those people have gone around. I am maybe the one person who stayed back here. The next event happened in 1987. A very good institute called Center for Cellular and Molecular Biology was getting inaugurated, and for a month-long conference with infinite number of Nobel laureates and top scientists from all over the world came. And I was a young faculty, I just lectured to assistant professor, published papers, very excited. I was a little sad that I was not called to give a talk. But in an international meeting, there are limited slots, everybody cannot. But I was very unhappy. So I thought, I should have got a 30 minutes lecture time, but I didn't get. So I decided, okay, I can ask questions. It's a 15 days conference. So if I ask questions, I don't ask 30 questions, I get my 30 minutes. Yeah. Right? So I asked my questions. I sat in the back, asked questions. Everybody turns around and says, watch this boy. Then Andrei Mirzabekov, the director of Engelhardt Institute, he walks up and says, who are you? What do you do? Right? I get, as I said, 78 questions. I knew Charles Cantor. 87 questions. I came to know Andrei Mirzabekov. Right? Then Indo-Russia project fund was available. So with that, I went to Soviet Union next year. We started working together. 1990, Hugo was formed. Andrei Mirzabekov and Charles Cantor were two vice presidents. Human Genome Organization, Soviet Union, Human Genome Organization office, so both were vice president. So I got elected. You understand? Yeah. So that's the outcome of questions. Yeah. Right? I made presentations in Society of Biological Chemists as a student, and then I asked questions. Right? So I met a scientist who came and said, hey, beta bolo aa jao. He was a big scientist in All India Medical Science who built a new institute in Delhi. Right? He said, तुमको ये नौकरी चाहिए आ जाओ. Only asking questions. You understand? So that's the way it goes. I was in France. Alexander Rich came to give a talk. He has just done tRNA structure and gold, made of gold, the structure, holding and talking. In France, rarely people ask questions because they have difficulties in English and all. So I asked question. He looked at me and said, where are you from? I said, from University of Paris, this lab. No, where are you from? Then I said, molecular. Now I understand. Right? Then I visited his laboratory as a guest so many times. Right? If I go to a conference, I'll go to Boston, he will drive me to that conference. I didn't have money to buy another ticket, no? So if I write to him, he said, no, come, in my car I'll take you. This is the power of asking questions. Right? It is you decide. That means you have to read, you have to know. And okay, sometimes you'll ask questions which might sound stupid, but so what? You can still ask questions. So I have seen in my life, throughout academic journey, asking question is a very important component. What does it mean? You can do your science well, that's fine, but can you find a question in somebody else's science which you have understood and then asked? Right? And that gives, everybody looks at you, that you are asking a question.